Good morning, this is your Stats Sensei, Mr. Spensei, and this is an exit ticket on regression, specifically on residuals, and we're going back to the problem from the warm-up where I can't drive 55. So let's take a look at our question. It says, use the computer printout in the data table to answer the following questions about the percentage of accidents caused by 40-year-olds. Okay, so let's take a look at the table. Oh, the 40-year-olds. There we go. So I went ahead and highlighted them because that's the age and that's the percentage of accidents. And this is our data table and our computer printout. It says what percentage of accidents caused by speeding? And it said observed. All right. Another word for observed is actual. So this could have also been, they could have also asked for the actual, but we want to see the observed, and we're caring about 40-year-olds. So when I look back and I go, oh, 40-year-olds, and the percentage of accidents is 24. So my answer is just a simple 24%. I really don't have to do much else other than the right to 24%. Although I want to make a point again that we could have called this observed, or they could have asked for actual. Now you don't need to write that down. I just need to make a point that it's could be observed or actual. And it says, based on the age of the driver and the linear model, what percentage accident was predicted? So we're looking for the predicted values, and they could have used expected. Well, to do that, I'm going to need my linear equation. Well, my linear equation is going to start off with y hat, and y hat equals 64.738, because we're going to just take it to two decimal places. So y hat, slide that down. There we go. 64.7384, because we're only taking it to four decimal places, minus 0.9606x. All right. But we know that our x variable is age. So I need to plug in age for x. So it's going to be y hat equals 64.7384 minus 0.9606. And the age we care about is 40-year-olds, so we're going to plug in 40. And we'll go ahead and run that real quickly. And 64.7384 minus 0.9606 parenthesis 24. And we get 41.684. So our y hat equals 41.684. And once again, this is our expected / predicted. They could have asked for either one, and it means essentially the same thing. The next thing it asks for is the residual for 40-year-olds. Well, residuals have the formula resid equals observed minus expected, or some people prefer residual equals actual minus predicted. Regardless, we already know the observed or actual was 24%, so we can plug that in. So the residual equals 24 minus our expected was 41.684. So our residual is that difference. So we'll just plug that in real quickly. 24 minus 41.684 is negative 17.684. So our residual is a negative 17.684. And because it was negative, we know that what actually observed was less, but we can sit there and go, hey, the observed is definitely less than what was expected. We can see that right here. But anytime you have a negative residual, you know the observed was less than the predicted. If it's positive, the observed was greater than the predicted. All right. I appreciate you watching, and I look forward to seeing you on the next one. Thank you.